It's third problem. So here what we need to find the LCM and HCF of the following integers by applying the prime factorization method. Just we need to find here the LCM and HCF values of these three numbers. So for 12, what are the values of prime factors? 3 4s are 12, 2 2s are 4, 2 1s are 2. And so for 15, 3 5s are 15, 5 1s are 5. And for 21, 3 7s are 21, 7 1s are 7. So for these two numbers, we have written like this. Now write the factors. 3 power 1 into 2 power 2. So for 15, what are the values? 3 power 1 into 5 power 1. So for 21, what are the values? 3 power 1 into 7 power 1. So observe, here 2 is missing. So let's write this as 2 power 0. Here also 2 is missing. 2 power 0. And here 5 is missing. So write it as 5 power 0. And 7 is also missing. Write it as 7 power 0. Here also 7 missing. So write it as 7 power 0. 5 is missing. So I am writing it as 5 power 0. Now what is the LCM? So now what is the LCM? LCM means least common multiple. That means we should take the highest power. So let's take 2. So in 2, what is the highest power? 2 power 2. In 3, what is the highest power? 3 power 1. In 5, highest power is 5 power 1. In 7, highest power is 7 power 1. Okay. So LCM is 2 square into 3 power 1 into 5 power 1 into 7 power 1. That is 2 square, you can write it as 4. 4 into 3 12. 12 5 60. 67 are 420. Like that, multiply two numbers and again with other number. Like this. 4 3 is 12. 12 5 60. 67 are 420. Like this, we need to multiply. Now write down HCF. What is HCF? We need to write the least power. So factor means least power we are writing. So what is the least power for 2 power? So 2 power 0. 2 power 0 is nothing but 2 power 1. Next 3. 3 power 1. 5 power 0. 7 power 0. So anything power is 0. Anything power 0 is 1. So 3 power 1 into 2 power 0 is 1. 5 power 0 is 1. 7 power 0 is 1. So 3 power 1. So HCF for these three numbers is 3 power 1. And LCM for these three numbers is 420. Understood? First of all, take the question. What is given in the question? So we need to find the LCM and HCF of these integers by applying the prime factorization method. So what are the integers given? 17, 23 and 29 are the integers. So we need to find the LCM and HCF. So observe the numbers. The number itself is a prime number. So prime numbers are having the factors 1 and itself. Itself is nothing but 17. So 1 and itself. For 23 also 1 and itself. And for 29 also 1 and itself, that is 1 and 29. So what is the HCF for this value? HCF is 1. So highest common value is 1. And what is the LCM for this? 17 into 23 into 29. That is equal to 11,339. So for these integers, the HCF value is 1 and the LCM is 11,339. Understood? Third problem, third. So here also we need to find the LCM and HCF of the integers by applying the prime factorization method. So what are the integers? 8, 9 and 20. 8, 9 and 20. So what are the prime factors for 8? 2 4s are 8, 2 2s are 4. 2 1s are 2. So what are the prime factors for 9? 3 3s 9, 3 1s, and for 25, 5 5s are 20, 5 1s are 5. So these prime factors we are going to find from 2 table to 20 table. Okay, 20 tables in between only this will lie. So check from this, and in this 2 to 20 we should select only the prime factors. Okay. Next, now write like the prime factors as a product of the prime factors. So how many 2's are there? 3 2's. That is 2. So for 9, how many 3's are there? 3 2's. That is 3 square. And for 25, there are 2 5's. That is 5 square. Okay. 8, 9 and 25. So we have written like this. Now, what is the HCF for this? HCF. Any common factor in these three numbers? No. So HCF for these three integers is nothing but 1. So what is the LCM for these three integers? 2 cube is 8, 3 square is 9, 5 square is 25. So LCM is nothing but 8 into 9 into 25. So that is 1800. So HCF value for these integers is 1 and LCM for these integers is 1800. Okay, understood? Today we are going to discuss exercise 1.14. So what is asked in this question? Given the HCF of 306, 657 is equal to 9 and we need to find LCM of 306, 657. So what is the formula or relation between LCM and HCF? Product of two numbers is equal to LCM into HCF. So product of two numbers is equal to LCM into HCF. Now, what are the two numbers? 306 into 657. And what is LCM? We need to find the LCM only. And what is the HCF? None. So we need to find LCM. Means that should be only on that side. So remaining term should come to this side. So 306 into 657 by 9 is equal to LCM. Okay, 9 table. 9 for the 9 3 is 27. So 30 minus 27 how much? 3. So let's write 3 here. Okay, 36. So 4 9 is 36. 34 into 657 is the LCM. After multiplying, with the multiplication, after multiplying, we got the value 22,338. So LCM for this value is 22,338. Understood? Fifth problem in exercise 1.1. What is the question? Check whether 6 power n can end with the digit 0 for any natural number n. So what do you mean by this? 6 power n అనేది 0 తో ఎండ్ అవుతుందా లేదా అని చెక్ చేయమంటున్నారు. కెన్ ఎండ్ విత్ ద డిజిట్ 0. సో 6 పవర్ n అనే నెంబర్ 0 తో ఎండ్ అవుతుందా లేదా అనేది చెక్ చేయమన్నారు ఫర్ ఎనీ న్యాచురల్ నెంబర్ n. సో ఎప్పుడైనా కానీ ఏదైనా నెంబర్ 0 తో ఎండ్ అవ్వాలి అంటే అది షుడ్ బి డివిజిబుల్ బై 10. సో దట్ ఓన్లీ we are going to write. If any number ends with 0, then it should be divisible by 10. It should be divisible by 10. So what are the factors for 10? Factors for 10. 2 and 5. So let's take 6 power n value as 1. So that implies 6 power 1. It is divisible by 2, but it is not divisible by 5. 6 అనేది 2 తో divisible అవుతుంది కానీ 5 తో అవుతుందా? అవ్వదు. అలాగే n వాల్యూ 2 తీసుకుందాం. అప్పుడు 6 power 2 that is 36. 36 is also again divisible by 2, but it is not divisible by 5. So like that, if you take any n value, it is divisible by 2, but it is not divisible by 5. Therefore, by observing this, we can say that 6 power n can never end with the digit 0 for any natural number. Therefore, 6 power n cannot end with the digit 0. Cannot end with the digit 0 for any natural number n. Okay, understood? If you like my content, please like, share and subscribe. Thank you for watching.